Okay, welcome back. I've just done a little bit of typing. I fixed up that annoying squeak in the accelerator pedal, and I've just been fooling around with the power a little bit. You can see how we did it. We've said the maximum power is slightly more than 9,000 units, I don't know what it is, for this particular engine. And then when we set the power, given a proportion that the accelerator is pushed down, we just set it to that proportion of the maximum power. And you can see here we are. You can call it new power, and then we assign it to power. Now, the reason I broke it into two lines like this was I thought oh, why is it complaining? Oh, 2 equals this. Good on you. Thank you, Eclipse. The reason I broke it into two was I thought at this point it's quite nice to I'd like to have some noise. I really like having everything being noisy. So let's have the engine making a noise. And I thought, okay, if it's putting out the same amount of power, it'll just make the same amount of noise. But if the power goes up, we could make the noise increase. Now I think about it even more, actually. The noise only depends on the power level, not the change in the power level, does it? So let's kill that. Let's say this dot power is that, and then let's make a sound. Oh, double equals again. So we'll say if this dot power is greater than 0, is greater than, say, 9,000, then we say noise. Engine noise. Let's just localize the print statement in one spot. Engine noise equals. Oh no, why is it not liking that? Oh, it doesn't mind. Over 9,000 goes. What's a really loud engine go? Brum. Actually, it's probably more. We can say brum for slightly less powerful. Maybe it's got a roar. Ha ha ha. And else if this dot power is greater than 5,000 equals that other sound. Did I just delete that other sound that I'd carefully saved? I did. Something like rum. And else if it's over 1,000 go brum. Or maybe not even brum, maybe it's vroom. Vroom. And else if the power is over 1, well, let's say it's over 0, see power at all. Engine noise equals silence. Alright, and then we'll just print it out. Now we could do all sorts of funny things about making the sounds longer, depending on the actual numbers and so on. Couldn't we have little loops that had things and all that sort of stuff? Engine noise. Okay, so every time we push the accelerator or release it a bit, we'll hear the sound of the engine. Okay, now, oh, we've got a little grumble here. What's that? We're missing a, sorry, missing a semicolon, variable, this dot power, it's not max power. What's the problem there? Acceleration proportion was this dot max power. Let's just pause. I'll be back in a sec. Hello, welcome back. I worked it out. It's max power here. We're using it inside a function which belongs to an object. But if you look at it, up here it's defined as a static variable, or constant really, it's final, isn't it? A static thing. Static means it belongs to a class rather than that particular object, which means a single instance of it is shared amongst every object. So although I could refer to it with this dot, and the objects one I guess will be delegated, will be just referred to the class as one, really either I shouldn't make it static and I should have every engine storing that value, or I should here say engine.maxPower. Say I'm getting it an attribute of the class rather than this particular object. Now, another thing we can do though, let me put it back to this.maxPower, is what about we say when we create an engine, we can specify its maximum power. That sounds good. So we could go, that could be default max power, and then we could have an actual variable called, which isn't final, called max power. It's going to be a bit long. Max power, private, double, max power. Now, here's what we do. When we create the engine, if no one says anything, then we'll say turning over is false. And the max power equals the default max power. But now we've got the scope to introduce another constructor, so there'd be two ways of building these engines, where we can specify what the max power of this particular engine is. I won't do that now, but maybe I'll leave that as an exercise or something for you to think about. Oh, no, hang on, we've still got a grumble here. It's never read engine.maxPower, it's never read local. Oh yeah, we don't use it yet, that's right. So, okay, there's the idea that we're setting max power, but it's possible now to construct engines with different maximum powers, but you'd have to have a constructor to do that. And the default constructor we've put in there, the one which takes no arguments, always gives you the default maximum power as its maximum power. And let's see why we don't ever use it. We don't ever use it because we've just changed it from a constant to a variable, so we've changed its case and into camel case. So it was this dot max, just max power, was that right? Alright, let's see how we go. Cool. Alright. We passed some tests, but we failed our car Java. Let's have a look. The accelerator. Setting the accelerator full on. What have we got? Another null pointer exception? Does that mean we never created an accelerator? Oh, well, that's not good. Let's create it. When we created the car, we made a brake, but we never made an accelerator. What does the accelerator need to know about when we create it? It needs to know about the engine, doesn't it? So we better tell it what the engine is in the car, and we're effectively connecting the two. By giving it a reference to the engine, it now knows how to talk to the engine. Alright, and, oh, sorry, don't create an accelerator using the brake constructor. You create it using the accelerator constructor, and now that's all looking pretty good. Right? Dun, 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 dun. Let's see how we go. Running the tests. Hello from car. Whoops. And the car tests. And let's have a look. Oh, look at all these exciting noises we're making. Let's read them through and we'll know what's going on. Forms of basic tests. Okay, we know those. Now it's going to do the exciting takeoff test. Whir, purr. Is it turning the engine on? What's purr? Is the purr coming from the... sound it makes when you turn the engine on, or is that coming from the engine itself with the set thing? Let's have a look. Where's whir per? Just looking for that. It'll be an engine, won't it? In the thing that turns on an engine. When we turn it on, it goes whir per. Okay, let's not do that anymore, because the sound the engine will make will now happen from when we push the accelerator pedal. Just the whir of it turning on. Okay, so whir, it turns on, then click, 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 click. So to remember that's the accelerator, isn't it? As we push the accelerator down, it clicks, but they're all on different lines. Let's put it all on the same line. How do we do that? Do we do it here? Okay. Click. The sound that saves me having to do with the terminal case, just being lazy. House, Buckland. Nothing. We'll just print a new line. Okay, let's have a look. Let's have a look. Basic test worked fine. Exciting test. Turn the engine on. Click, 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 click. We've jammed the accelerator all the way down, and so the engine now gets a message, and it goes roar because it really is now at 9,000.01. Is that right? That's the right sound for 9,000.01. Where's our engine? When do we roar? Yep, that's over 9,000. Then we've got a squawk. Squawk. That's the squeaky brake. What's happening with the brake? We're letting the brake off. Why is it going squawk? I thought I'd fix the brake. If the brake position is less than the old... Oh no, it's if it's more. Yeah, if we push the brake further down. So if the brake's going down, there we go. We make a noise, otherwise we don't. So we shouldn't have any things. Exciting brake takeoff test. Squeak. We're pushing the brake all the way down. Whir. We're turning on the engine. Click, click. We're accelerating. Click, 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 click. We've got an assertion thrown. The assertion, this is interesting. Notice the assertion happened here in the middle of all our printouts. It didn't mean it literally happened in this place in time. It didn't mean we printed 2 clicks, then we got the exception. Well, it does, but it didn't mean the program generated 2 clicks, then it got an exception, then it kept clicking for a while, and then finally it stopped. What happens is the prints to the screen get buffered and take a while to come, and the program hasn't quite printed them all when already at lightning speed it's reached the problem, and it looks like the error message got there a bit faster than the rest of the prints did. Maybe it's got some sort of priority, or maybe that's just some sort of race condition or whatever. But anyway, so we got the error message printing before the actual message is printed out, which is an interesting thing to know, I guess, if you ever see it, that you can't rely on the sequencing you see here to tell you exactly what's going on. They might be in different threads or something like that. I assume that's the case. So what happened? Click, 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 click. The accelerator went all the way down, then we roared. So the car's going fantastically. Now, hopefully now someone's about to release the brake, but we've got a problem. The takeoff in test car Java 54, let's have a look. Taking the foot off the brake, and the assertion saying, oh, okay, we've taken our foot off the brake, but we're not speeding. Why not? Well, it's because we haven't connected the engine to the wheels yet. So although the engine's roaring away and the brakes are off the wheels themselves aren't doing anything. So we'd better connect the engine to the wheels. So let's have a look what we've got here. The engine, when we set the power, we make a lot of noise. We print out the noise, but we didn't do anything else. Well, still a lot of people like that about their car. I think the noise is just as important as anything. In fact, I heard a story once that one manufacturer of cars, of fancy sports cars, made their engine so silent that when you're inside, you couldn't hear the engine roaring away. I can't remember which manufacturer it was. And actually people complained a bit. Normally they'd like not to hear the engine, but when they're pushing the accelerator down, they really did want to feel that they were being very loud and masculine and virile and things, and they wanted to hear that roaring sound. So I don't know how the manufacturer fixed it. Perhaps removed some soundproofing, though that would increase noise all the time. Perhaps they put a little speaker inside and played a fake noise, or just had the engine whispering, "You are very virile," when you pushed it down, or something like that, perhaps, as a proxy. Now, we need the wheels to be told to be this power that we're generating from the engine has to be transmitted to the wheels. So let's do that. This dot wheels dot. Now, what methods do we have inside wheels already? We've got something to transmit the braking force. Yeah, I just want to keep the name similar. So let's go set driving force, maybe. Set driving force. And it's the power. No, I'm sure I've got the units wrong now, haven't I? Set driving force to be this dot power. Now, actually, there's no actual need for us to store the power, is it? We don't seem to be using the old power at all. We could just throw the power away once we've transmitted it to the wheels. But of course, in any real model, the power is constantly transmitted, not just at the instant you push down the pedal. But we're simulating it here, and we're only really printing out messages at the time anything changes. So I don't actually have to store the old power. So we could sort of set driving force this dot power. We could just set the driving force to whatever we've called it. Oh, we've saved it directly in this dot power. We could just make that a local variable rather than an attribute. Okay, but let's not, because I want to finish this as quickly as we can. Now we've got some messages that are unhappy. Someone's unhappy. Who's unhappy? Is it a missing brace? So this finishes set power. Oh yeah, sorry. Let's see. The line I just wrote then wasn't inside the set power function. It was just sitting out in the void. There we go. So now the wheels are being given the driving force, and that's all we do. Okay. What's the problem? Create a field wheels and type engine. Yeah, absolutely. The engine needs to know the wheels. So connect it to it. What were we doing before? We didn't store them. Doesn't know what class it is. So I just went for the most general one, object, because that would work, but we know they're actually wheels. The wheels are wheels, luckily. Alright, and I guess when we create the engine, wheels, and pass in some wheels. How's that looking? That's looking much better. And unresolved compilation problem. Constructor engine is undefined. Alright, so the constructor for engine which has no arguments is undefined, because now we've given our own constructor which has arguments. Java is not going to just do the default thing. Once you've started giving your own constructors, it expects you to give all the constructors. If you leave some out, if you leave all of them out, it'll give you the default one with no arguments automatically, which does nothing. But if you start sticking them in, then it expects to see everything. And if you want the one with no arguments, you've damn well got to write one with no arguments. Sounds like we're using one with no arguments, and that's why it's unhappy you can't find one. And let's have a look. New engine. Yeah. Well, the engine needs to know about the wheels. Oh, well, then we'd better create things in a different order, because we better make the wheels before we make the engine. This dot wheels equals new wheels. This dot engine equals new engine given the wheels. Let's just check the engine. Yep, all looks good. We're running it. Click. Oh, now we've got another problem. Set driving force is undefined in wheels. Oh, okay, so we sort of knew that. Where are we? We're calling this set driving force function. We're sending the force to the wheels. We haven't told the wheels about that yet. Let's just set braking force. No, create a method called set driving force in wheels. Thank you. And we'll be this dot. Start driving force equals power. Okay, so the wheels are having two things acting on them, and we'd better remember that. It's getting a driving force from the axles. It's getting a braking proportion from the brakes. Now, these two things will have to fight each other and resolve into RPMs, or the speed of the wheels, the number of times they turn. but we don't have to do that yet, not until we're required to do it. So let's see what we got. Squeak, that's the brake going down. Roar, we're turning on the engine. Click, 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 click. We're pushing the accelerator all the way down. Roar goes the engine. And now we're getting an assertion error. And presumably that's just the one saying the speed hasn't increased. Okay. So now we get to the real meat of the problem, which I've been deferring as long as possible. And lo and behold, the size of the problem's been shrinking as we've been deferring it. So isn't that good? Where we've actually got to work out the speed of the car. Now we're going to get the speed of the car from the speedo. So let's defer that to the speedo. Where has it been called? It's been called in test. Get speed in car. So it must be in car, just not doing anything. Can you see get speed? Let's have a look. Get speed. Ah, yeah, it always says the speed 0. Well, what a safe car. This is for a Volvo. But we don't want a Volvo. So let's go. Get speed has to speak to the engine. So what's going to return? It's going to return, no, not the engine, the wheels. Let's think, the wheels will know their RPMs, won't they? And they'll convert that, tell that to the speedo, and the speedo will convert that to an actual speed. So we just need to go ask the speedo what the answer is. Return this dot speedo dot get speed. It's returning an int speed. Maybe we should make that a double. And that function doesn't exist, so can you please make it for us? Thank you. Right, so now our speedo class finally has something called get speed. How's it going to get the speed? Well, it's going to get the speed by finding the RPMs, the revolutions per minute, from the wheels. Alright, so it needs to speak to the wheels. So we'd better do that. When we create the speedo, we'd better tell the speedo about the wheels. Oh, gee, the wheels are turning out to be quite important, aren't they? We're doing them first, that's good. Right. So this dot speedo equals new speedometer. But we've got to tell it about the wheels. Okay. All right. And now we'll need a constructor for speedometer that tells it about wheels. It's all looking good. Thank you, guys. And we simply say store the wheels or a reference to them. And now we create the field. There we go. All done. Now get speed, how's that going to work? Public double get speed? Oh, isn't that a function? That should be a function. Did we not make that a function? Look at get speed down here. Oh, we didn't. Just made it a variable. That's not good. It needs to be a function. Okay, get speed. How's that going to do it? Well, that's going to find wheels. We'll ask the wheels what their RPM is. And then we'll do some maths. Oh no, can I do that? Alright. Yes, we can do it. Alright. Let's go double meters per min, double meters per revolution. I'm giving everything names just so you can see all the intermediate steps named. If we were doing this calculation rapidly or frequently, we'd probably cut a bit of speed by not storing things into local variables. Though maybe the compiler will be clever enough and optimize it. I'll just pause this because there's someone at the door. Okay, nearly there. I've just coming back from the door. I checked the diameter of tyres by Googling it. It looks like they're about 24 inches. So an inch is, well, what? It's about 25 millimeters times 25 equals 600 millimeters, or 0.6 of a meter. All right, so meters per revolution equals approximately 0.6. Okay, and piston wheels get RPM. Let's have a look. So we go get the meters per minute equals the RPM times meters revolution. Okay. Though now I think about it, this should probably be a constant. Maybe when we create the wheels, we could have wheels of different diameters. So we might change this with different constructors. So that's just me justifying not having to change it. So we've got meters per minute is that. So meters per hour equals meters per minute times 60. That's only good. 60.0, I guess. Make it clear it's double. And so to return the speed in kilometers per hour, we return meters per hour divided by 1,000 to give us kilometers per hour. Okay, let's have a look. Is that all looking good? Yes. Okay, so all we're missing now is a function called get RPM from the wheels. And that's going to be, we have to scratch our heads a bit. We've got this braking proportion and driving force. What's a reasonable way of converting that to RPM? Well, what about its... It's a stupid way of doing it. I really don't know anything about the physics of cars, so at this point we're going to break down. We just want to come up with something that's not too ridiculous. What about return the power just times the braking proportion. Yeah, what do you think of that? I like that, because if the braking proportion is oh, hang on, does braking proportion increase as we apply more force? Yeah, it does. So it's times 1 minus the braking proportion. So the idea is if it's 100% braking, then 1 minus that's 0, so we get no RPM. If it's 0 braking and our power is 9,000, then we'll be doing 9,000 RPMs. Gee, that sounds a lot. But anyway, okay. We'll see. I have no idea if we're going to get ridiculous number or sane numbers, but at least we'll get some numbers out of this. Well, if it compiles, let's have a look. We've got, what's the problem here? Squeak, turning on the engine, unresolved compilation problem, power cannot be resolved and is not a field. This dot power. Oh, it's not called power. What's it called? This dot driving force. Sorry. I think you'll probably give me that sensible suggestion here. Thank you. Alright. Woohoo, this looks good. About to perform exciting takeoff tests. Squeak, whirr, click, 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 click. So the accelerator's all the way down. Roar goes the engine. Squeak as we... Oh, then we let off the brakes, which is silent, but then we jam the brakes on again. Squeak, and we come to a halt, and all tests are passed, and we are awesome. Yay! So it all worked. Just for fun, let's see how fast we were traveling then. It's just a random number, isn't it? Let's have a look though. It wasn't in car, it was in, where was it? It was in our tests. How fast are we going? Dot out dot. Maybe we can print a warning. Warning. You are traveling at, hope it's not a ridiculous speed, add on car 120C dot get speed. And let's go. Morning, you're travelling at 324. Oh, that's not too bad, is it? Oh, how about that? By sheer coincidence, we claim no credit for that. We haven't got a ridiculous number. Kilometres per. All right. Rather spurious accuracy there. You're travelling at 324 kilometres per hour. Woohoo! In fact, let's convert that to an int. We shall round it for us. That's looking better. Okay, fantastic. Well done. So I hope all that makes sense. Put lots of other fun sounds on. You can connect things up more yourself. A challenge for you, or several challenges. One is how would you put gears in? How would they go? Obviously, if you think about it a bit, they should slip somewhere between the driving force from the engine and the wheels, I guess. And then perhaps putting in more sensible numbers, putting in other acceleration and deceleration functions. The ones I was thinking of putting in were things like push pedal down a bit more and push it a bit less. So brake a bit more, brake a bit less, accelerate a bit more, accelerate a bit less. Perhaps you could have interesting sounds when you're accelerating and braking at the same time. Perhaps you could cause the engine to stall under certain conditions like that. And the other thing is working out two classes that are very similar, the accelerator and the brake. That's not good, is it? Look to see what commonalities there are there and pull the common stuff out and have some sort of pedal class or something like that. Okay, so I hope you've understood and followed this little fun fooling around with modelling a car to get a sense for how we can model a physical system or a collection of physical objects using Java. Okay, bye. Oh, when I say bye, I really mean